Welcome back to this video on the ESP32 and its ADC. In this video, I'll be going over how we get the voltage across the PT1000 from the digital reading that we've got on the ESP32's ADC. I said in the last video that the ESP32 is a 12-bit microcontroller, and if we take 2 and put it to the power of 12, we get 4096. This means we have 4096 possible digital readings that we can get as the voltage across the PT1000. The lowest digital reading we can get for this 12-bit ADC is 0, and the highest is 4095, because if you start counting at 0, everything's offset by 1. Say we got a digital reading of 1000. We want to convert this 1000 into the voltage that it represents across the PT1000. The digital readings from 0 to 4095 act a bit like a scale, with 0 corresponding to the lowest voltage that the ESP32's ADC can read, and the 4095 corresponding to the maximum voltage or the reference voltage that the ESP32 can read. That means to get our 1000 and convert it into volts, we need to get 1000 divided by 4095 and then multiply that by the reference voltage of our ESP32. If you take 2 different readings of voltage across your PT1000 and the digital readings are 1000 and 1100, you might be tempted to take them both and say that the difference between them is insignificant. Don't do this, because even though there's only a difference of 100 between them and the scale goes all the way up to 4095, it might seem insignificant, but it's not. This will have a significant effect on your voltage, and as a result, a significant effect on the temperature that you record. So please be wary of any small little spikes. I mentioned the reference voltage earlier, which is just the maximum voltage that the ESP32's ADC can read. If you put a voltage across the PT1000 that is higher than this reference voltage, then it will just output the digital reading of 4095. This is called saturation, and if it's the same on the other end. If you put through a voltage that's less than 0, it will just come up with 0. It will flatline. The reference voltage for every ESP32 is different, and if you don't believe me, here is 10 different ESP32s that we measured the reference voltage of. 2.89 volts, 2.81 volts, 2.84 volts, 2.76 volts. That's a significant difference, so you will need to measure this yourself, because if you multiply the fraction, the digital reading, divided by 4095 by the wrong reference voltage, you'll get a different voltage, and then you'll get a different temperature, which is not what we want. Saying all this, the ESP32's ADC is inaccurate. Fortunately for us, these inaccuracies are consistent, which means we can calculate a correction factor for the ESP32's ADC, and this will be covered in the next couple of videos in this series. Thank you for watching.